every time so far when we've been using the quadratic formula to solve them, our discriminant has been a perfect square or 0, which 0 is actually could be considered perfect square also. Well, today our discriminant sometimes will not turn out to be a perfect square. And what happens when you try to take the square root of a non-square number? You get a decimal. And remember that decimal never repeats, never ends, so we can't even write it as a repeating decimal or a terminating decimal. We have to round it. If you remember right, back when we were using square root method for solving these quadratic equations, we were rounding to the nearest 100. So that's what we're going to have to do in these problems is we're going to be, sometimes we're going to have to round the, when we're taking the square root of the discriminant in the middle of the problem, we're going to round to the nearest 100. Okay, let's start with number 1. Is it in standard form? Mm-hmm. Okay, it's in standard form already. So we're going to identify our what, Brian? What's our first move here? Identify A.
Oh yeah, A and B and C.
Okay, let's do it. A equals 1. B equals 8. And C equals -1. Okay, we all have the quadratic formula memorized? Mm-hmm. Yeah, you got it? Okay, so we're just going to go right to subbing into it. How about we write it one time together? X equals, what do we have?
B.
Opposite of B, negative B.
Plus or minus.
Plus or minus.
The
Square root of.
B squared minus 4AC.
What's that thing? What's that B squared minus 4AC called again? The discriminant.
Over 2A.
Over 2A. Okay, there's our formula that we're going to substitute into again today. So we have, in ours, we have, and we're going to, I kept catching people with this yesterday, so let's just get on board here. Everything we substitute in, let's just put it in parentheses. So that negative sign is part of the formula. Our B value is 8. We'll put that in parentheses. Add and subtract the square root of 8 going in parentheses because we're subbing it in. We're going to change our subtraction to add the opposite, make that a -4 plus a -4. Substitute in a 1 for A and a -1 for C. And then we do not forget about the denominator. 2 times 1. So everywhere you see a set of parentheses should be a substitution. And we sometimes use the B value more than once. We use the A value more than once. And we only use the C value one time. Okay, now we starting to simplify this. So we say X is equal to, what's the opposite of 8? Negative 8. What's 8 squared? 64. What's a -4 times a +1 times a -1? +4. So we're just getting rid of all our parentheses. And 2 times 1 downstairs is 2. Okay, now, here's where you're going to be tempted to say, well, 64 is a perfect square, and 4 is a perfect square, so why can't we just take the square root of 64 and take the square root of 4 and then just add those two numbers together and presto, we'll have what we need? Because you can't. That's right. You have to simplify before you can take the square root. So our next move would be to say, okay, we have radical what? 68. Is 68 a perfect square? No. So as soon as our discriminant becomes a non-perfect square, this is when we're going to have to round. Okay, so we're going to do that step next. Just like we would do in what we did before, we're going to simplify our radical part. So we're going to say X is equal to, before you even do it, get this much written down, -8 plus or minus. And now on your calculator, take the square root of 68 and round it to the nearest 100. So who wants to offer up what 68 rounded to the nearest 100 is? Caitlin? 8.25. Everybody make sure you can get that on your calculators. And you can, it's important that you round here correctly. Okay. Now we're going to break this into two separate problems. Now we say, okay, I have really x equals negative 8 plus 8.25. All of that divided by 2. And I have x equals negative 8 minus 8.25 divided by 2. Don't shortcut this step, write it out. So in the next step, for this one I'm going to have x equals a 25/100ths divided by 2. And in this one I'm going to have a negative 16.25 divided by 2. So we round to the nearest hundred in the middle of it, and if you need to round again at the end to the nearest hundred, you do it again. So do we have to round this one to the nearest hundred? Doesn't it come out to 0.125? Yeah, so we're going to round that to, what would we round that to?
1.3.
Yeah, we're going to say, so here we have to do this right here. X is approximately equal to 0.13. Approximately, use your squiggle sign. We rounded twice. And then on the other one, we're rounding also, because in reality, you know what, we really should start using our squiggle sign all the way back here, because that's where we rounded, was for that 8.25. So we should kind of be, from that point on, we should be using our approximately equal to symbol, so we don't forget. So this one rounded to the nearest hundredth. What does this one come out to?
Negative 8.13.
Okay. So again, this one comes out to a negative 8.125, and that 0.125 can be rounded to 1300ths. So x is approximately equal to 1300ths and negative 8 and 1300ths. Now, be careful though. Don't assume that all the time those hundredths have to match up like they are right now. Yeah, we don't want to start making assumptions on things until we see it happen so many times that we say, you know what, I can count on this. But right now we're not ready to count on anything. We're going to go through all the steps. Any questions? Okay, well, let's go to the back side and do one more together. Jossie, is this one in standard form?
No.
Okay, could you give me what it would be in standard form, please?
2x squared minus 8x plus 1.
So we have to subtract 8x from both sides
And then
and add 1 to both sides to get it in standard form, right? Levi, what are my A, B, and C?
2, negative 8, 1.
Okay, A equals 2, B equals negative 8, C equals 1. We're writing all the stuff down. Everything, standard form, what does it look like? What's our A, our B, and our C? And then we're ready to substitute into the quadratic formula from memory. We're going to try it. So x equals the opposite of negative 8. That negative sign has to be there, it's part of the formula. Plus or minus negative 8 in parentheses squared. I'm going to change it to plus a negative 4 and times 2 times 1. All over 2 times 2. Okay, you go ahead and finish this problem up. Let's see if we can get the same solutions. I'll work here, you work at your desk. gonna be really easy to get, like complacent about these. You're gonna be like, I'm not gonna even answer this an integer value anyway, so I must be doing it right. It's okay. Make sure you take your time, do the steps. It's very easy to get one little thing wrong in doing the quadratic formula, and the whole problem ends up wrong then. Okay, what'd you guys give for a solution? What's one of them? Hand up. One of them. Jesse, what'd you give for one of them?
3.87.
Okay, x is approximately equal to 3.87. Okay, and Matt, what's the other one?
0, x is approximately 0.13.
Okay,
I thought do we have to put that squiggly line
Yes.
if it doesn't
Yep.
have numbers behind it?
yep, we do, because actually what happens is we rounded earlier in the problem, so all you have to do is round one time in the problem, and that squiggly sign has to be there. So because we rounded back here, notice I started with my squiggly sign right here, because I had rounded right there, and then that way I won't forget to use it in the solution also. Okay, notice our decimal points, our parts this time, do they match? 0.87, 0.13. We just threw that theory out the window then, that our decimal points will always match. So again, we can't assume anything until we see it happen so many times. We say, I'm thinking that this will always go through. Well, we threw the decimal parts will always match when we round.